Hi, we're looking at problems in section 7.6. This is the section on integration using tables. The first problem that we're looking at here is the integral of x times the square root of x squared plus 16x plus 67. So something I would like to quickly point out, if you look at many of the table formulas, you will see that a great chunk of them include expressions in the following form: u squared plus a squared, u squared minus a squared minus u squared. And so what this tells us, if we're dealing with a quadratic equation, is that we need to complete the square. And so hopefully it will fit one of those forms. So let's start here by completing the square on that quadratic x squared plus 16x plus 67. So if you look at the middle term, the b term here, that is 16. Half of 16 is 8, and 8 squared is 64. So we know 64 is the ideal constant here. It is the constant that would cause a perfect square. So I'm going to go ahead and insert a 64 for myself, but I'm going to just subtract it out again to make sure my equation remains balanced. And then if we just regroup, we can see that the terms x squared plus 16x plus 64 becomes a perfect square. That's going to be x plus 8 quantity squared, and then 67 minus 64 is just going to be equal to plus 3. So let's just quickly recap and then see where this got us. So this means that we are looking at the integral of x times the square root of x plus 8 quantity squared plus 3 dx. All right. So let's keep going here with this integral. The next technique that I might need to use here is going to be substitution. And I'm going to I'm going to reserve u for later. So let's let t be equal to x plus 8. All right. So that means it follows then that dt is equal to dx. And also it means that x will be equal to t minus 8. All right. So if we go ahead and make our substitution, we're going to get the integral of t minus 8 times the square root of t squared plus 3. And again, a simplification here. If you go ahead and distribute the t minus 8 term, we will get the integral of t times the square root of t squared plus 3 minus 8 times the square root of t squared plus 3. All right, so again, just splitting up that integral is going to give us the integral of t times the square root of t squared plus 3 dt minus 8 times the integral of t squared plus 3 dt. So really I have two separate problems. If we look at it at the left-hand side, we see this can fairly easily be done using substitution. So by substitution, I'm going to use w substitution here. Let w be equal to t squared plus 3. So it follows then that dw is 2t dt, and 1/2 dw is equal to t dt. So if we go ahead and make our substitution, we'll end up with 1/2 integral of the square root of w dw. I'm going to just rewrite that as 1/2 integral of w raised to the power 1/2 dw, and then integration gives 1/2 times w raised to the power 3/2. You can either divide by 3/2 or multiply by 2/3. Again, further simplification here gives 1/3 w raised to the power 3/2. And then when we back substitute, we get 1/3 times t squared plus 3 raised to the power 3/2. The second part of the integral, the 8 times the integral of the square root of t squared plus 3. Actually, let's leave the 8 aside for just a second and just look at the integral. This is going to be evaluated using a table, and here specifically, we can use table 21. All right, so if we use table 21 here, we can plug in and we're going to get the integral of square root of t squared plus the square root of 3 quantity squared dt. So doing our substitution properly, we let u be equal to t, which means du is equal to dt So that means that a is going to be equal to the square root of 3. All right, so when we plug in, we get the integral of square root of u squared plus a squared. And using our table to evaluate, we get t over 2 times the square root of t squared plus 3 over 2 times the natural log of t plus the square root of t squared plus 3. All right, so now we just need to put our final answer back together. So putting all of this back together, I get that this is going to be 1/3 times t squared plus 3 raised to the power 3/2 minus 8 times t over 2 times square root of t squared plus 3 3/2 times the natural log of t plus the square root of t squared plus 3. And then finally, we do need to plug back in. And plugging back in is going to give 1/3 times x plus 8 quantity squared plus 3 raised to the 3/2 minus x plus 8 over 4 times the square root of x plus 8 squared plus 3 plus 12 times the natural log of x plus 8 plus the square root of x plus 8 squared plus 3.